Let's start at the beginning, if possible. Yeah. So thank you for the introduction. Yes, my name is Forrest Hoffman. I'm from Oak Ridge National Laboratory. And I want to also thank the other contributors to the work, which we're just beginning, actually. Ian Foster here at Argonne, Sasha Ames at Lawrence Livermore National Lab, and a number of our colleagues at all three of the institutions who will be working on this, this next generation Earth System Grid Federation. But let's start with what is ESGF now. So it's actually, in case you don't know, it's a globally distributed peer-to-peer network of data servers that provides access to all of the climate modeling and Earth system modeling output from data center, from modeling centers all over the world. So these simulations are run at big supercomputing centers in various countries using a variety of Earth system models or climate models, or GCMs, as you may have heard them called. And then all that data is used by scientists who do analyses after those simulations. And in order for the scientists to get access to the outputs that they need from all of those hundreds and often thousands of simulations, they need a big data system. And so this is a fully distributed peer-to-peer network where, for instance, the simulations that were run in the UK live on data servers in the UK, but they all share indices and talk to each other. So as you can imagine, it's a pretty complex data system to run. But you may have seen recently that the IPCC released the 6th assessment report, the Working Group 1 report. I think the Working Group 2 report came out fairly recently, and maybe even the Working Group 3 report. And so these reports are the product of all of the United Nations government's contributions to studying climate change. And all of the modeling information about future projections comes from the data that are distributed by the Earth System Grid Federation. So to us, this is a really important data system, right? I'm sure everybody's data is really important to them, but to us, it's about the future of life on Earth. And so what can be more important than that? So we've got to make sure the data are accessible and reliable, findable, interoperable, all of those things. The holdings right now, this is actually a bit dated, but simulations are sort of trickling in now much more slowly than when the models were first run. But you can see the latest CMIP6, the simulations that were done for that 6th assessment report constitute about 20 petabytes of data in that system. And then the prior, CMIP5, these Cordex are some more high resolution simulations that are done regionally over shorter time periods typically than these simulations. But all of these are separate data projects within the Earth System Grid Federation. And you can see that more and more of these will be coming online as we do more research. We also have some other data projects that provide the input data for running those simulations, because those simulations need to follow the same protocols in order for them to be comparable and easily intercompared. And then we have some observational data as well out there that's been refactored so that it's very easy to compare with model output. And so we're kind of growing those suites of data as we go along, working with NASA and other agencies to build up these data sets. So we've recently formed a new consortium to modernize this system. And as I mentioned, it's composed of a group of us from Oak Ridge, Argonne, and Lawrence Livermore to modernize that sort of data backplane that drives this information system based on the Globus platform. So that's our proposal. It was reviewed by a number of scientists and selected for funding by DOE, which we actually just got about a week ago. So in collaboration with the ESGF Executive Committee, which is composed of people at all of these other data centers in Europe and Asia and the US, who work collaboratively to design and build and deploy the system, we're going to develop new architecture based on an architecture roadmap that's already in existence, but deploy it on the Globus platform. We're hoping also to build out new data discovery tools and data access interfaces, as well as deliver server-side computing for users so that they can compute near the data without having to do transfers down to their own site, although that will still be possible. And then user computing and user and more system metrics so that we can do better tracking of what people need and try to anticipate where it should be and how, what's the best place to stage and hold these data, because that's where they're being accessed the most. We're going to add some additional governance mechanisms within the existing governance of the Earth System Grid Federation, so that we also do a better job of working with the community to understand what their needs are. So the current, this is a very US-centric, obviously, view of the current ESGF. But as you can see, we've got a number of partners all over the world that are operating and delivering data from their own model simulations. And then in the US, we have a primary node at Lawrence Livermore National Laboratory, another node at Argonne, and some others scattered around at other institutions that provide access to these data in this sort of peer-to-peer distributed fashion. And what we're planning to move to is a different layout, but right now, Lawrence Livermore is replicating from all of these other sites, when it's able to, all of the medium to low frequency model output, so that there's a copy of it if one of these sites disappears. One of the things that's of interest right now is that some countries are blocking Russian IP addresses for some reason. And so we want to make sure that we have a copy, a replicated copy of the Russian model simulation output on our own server. So that's something that we're sort of building in and working on right now. But our plan is to build a more distributed layout within the Department of Energy, so that we have data at Argonne, Oak Ridge, and at Lawrence Livermore National Laboratory. And not coincidentally, this is where the three big computing centers are for DOE, right? Summit is at Oak Ridge, right? And machines are coming. There's a exascale machine being built for Argonne as well. And Livermore is right next to Lawrence Berkeley National Lab, where NERSC is. So these, it's no coincidence that that's where we're deploying the data, so that when we get to the point where we can live stream, for instance, some of these data to drive downscaling simulations on the big machines, they'll be sitting right there, right, in a different network enclave, but have high-speed access. But our plan is to do something like this, as well as add tape backups for what's spinning on disk. Right now, all of the data are at Lawrence Livermore, just on spinning disk, right? So we want to deal with that, and I'll remind you about a project that we just did to help ameliorate some of those problems. But our plan is to have an open architecture and protocols. So that's all standardized and in the architecture plan already. We want to use highly available and scalable central services from Globus, proven and modern security technologies and practices. So we want to really enhance the security of the data backplane and the interfaces for the modern world, and really provide a use case approach to our design and implementation. And that means more interactions with users and the community, as well as better instrumentation, integrated instrumentation, so we know where the data are being used, where they're being moved, who's using them for what, and focus on performance, right? To deal with big data. So we need to make sure that we have high-speed data transfers, search, server-side processing, et cetera. And so we've been building out sort of vignettes like this, where we consider a typical researcher like Samantha here maybe presented new data, code, and papers relevant to her research, and she may find something of particular interest, for instance, in extreme precipitation data. And so she looks at a Jupyter notebook that implements some method for that analysis, and wonders if the method would work with higher resolution data from a different model like E3SM, which is DOE's Earth System model. So she locates the required data sets through ESGF2 and runs the notebook on a subset of those data, shares them with a collaborator via federated storage, and they agree that a larger ensemble analysis is called for. So maybe she's able then to launch some simulations that run overnight, say at the Oak Ridge Leadership Computing Facility here. And then within 24 hours, she has new results. They're automatically published onto the Earth System Grid Federation for broader consumption. And then she relaunches her notebook and they collaboratively do an analysis of the high-res data. So this is sort of an idea of one of those use cases that we would like to be able to support for our user community. This is sort of a layout of our architectural plan. So we have an ESGF web app that lets you search and transfer and publish data, as well as the data nodes that would be sitting at 3 sites, although we will deploy these at many sites, including you know, in the cloud, like Amazon. Amazon currently has a data node, but they would be built upon the new architecture. They'd be built upon these sort of central services from the Globus platform. ESNet Connectivity provides us very fast access within the US to these national laboratories. And you folks that are using these resources for, you know, physics and health information and other kinds of science applications know that it's very quick to do these data transfers. And of course, DOE ESNet also has very high-speed access to parts of Europe, particularly where they have accelerator systems. And so this will allow us to continue to be able to download a lot of those data very quickly. We're planning to build out a new data discovery platform. So we have some architectural ideas there to get people more like policymakers and people who are less familiar with the models better interaction with these data to make them more usable. We have about 13 folks associated with the project. There's currently in ESGF a steering committee and an executive committee. These are people who are from various organizations around the world who are working actively and collaborating to build out ESGF. And but we're going to add to that sort of resource and project liaison. So this includes a representative from ESNet, representatives from different laboratories and different projects that DOE is also funding that need special attention with regard to ESGF. And then a sort of advisory board that includes scientists at universities, people that want to use the data and need access to it. We're planning to organize webinars, tutorials, and boot camps just to make the data more easily accessible and usable. We've already actually had one hackathon within another part of DOE around these data so that people can begin to use them for analysis. And there's some projects that didn't previously use these model simulations for analysis, and now it's a major part of the research papers that they're writing, as well as organizing a developer and user conference for the software itself. We also have never had really a help desk, and so we're planning to try to build out a help desk. And that's hard for old architecture, right? So we don't want to turn this on too fast because we'll just be drowned in lots of questions about old architecture, right? So we want to sort of bring this online as we begin to deploy new, more reliable, scalable systems. In the US, as I mentioned, Lawrence Livermore Lab operates the primary ESGF node that replicates a lot of the CMIP6 and related model output from around the globe. Since these data were only on spinning disk in a GPFS file system, about 7.5 petabytes, we recently decided that what we need to do is make a copy of this before we lose it. And so we used Globus to transfer the files over ESNet to both Argonne and Oak Ridge. And Ian mentioned this in his opening talk this morning. We used a lot of Globus scripting, and folks helped us from ESNet to do monitoring and diagnostics, some custom configurations of DTNs and GPFS, and debugging and problem solving from lots and lots of people made this possible. This is a sort of a snapshot of what was going on March 10th, when about a quarter of the data had been copied from Livermore to Argonne and Oak Ridge. And you can see that the slow part of this pipe is this one, right? Getting the data out of Livermore. So the transfer was designed to ensure that we keep this part of the pipe full, no matter what's going on here, because these guys can talk to each other very, very quickly. Now it looks like this, right? All of the data have been copied in between mid-February and May 4th. So in less than 3 months, we made a full copy of the 7.5 petabytes to 2 sites, moving it through the slow part of the pipe once. So this is a, a pretty nice story, and it's I'm sure that this is nothing for some, high energy physics data, but this is the biggest earth science data set collection that I am aware of. And it's, fully international. So lots of directories, lots of files. Ian showed this one as well. This is sort of the transfer time, as I said, from like mid-February when we started off kind of slow to the very end. And you can see that there's a dip down here, and I'll show you that on the next slide as well, when ALCF was offline and we were just sort of figuring out what's the best way to optimize these transfers. And this little slowdown up here, which was due to the fact, due to some configuration problems in GPFS, which I think were really a result of the fact that we moved the current data first and we moved the older stuff last. And the older stuff has lots more smaller files. And so that's a sort of re-optimization of how you deal with many more smaller files. Now we make many fewer bigger files, right? Which makes perfect sense. In addition, there were some giblets out there, right? There were some like dot files hanging around, some unreadable files, things like that caused problems on some of the transfers. And then these are the transfer rates over time. And you can see that during that argon downtime, the data were moving through this pipe, right? We can't get anything through the pipe faster than this, right? So nothing from Livermore is going to be higher than that. But we were moving it to Oak Ridge. And then once argon came back on, they started moving data, but then they're constantly pushing it to Oak Ridge as the green lines. And Oak Ridge then sent everything it had to argon very fast, up to 8 gigabytes a second, which is pretty darn good, right? So that connection is super fast. And then you can see that as the different centers have had downtime, then the other center picks up, so that we're keeping that Livermore pipe full all the time. And that's how we were able to do it in such a relatively small amount of time using Globus. So again, just to summarize, our project's just starting up, but we're hoping to redesign and modernize the system and bring a lot more reliability, scalability, and speed to the process, as well as give users better access and easier access to the data instead of having to transfer everything and download it. The Globus platform is expected to provide a lot in the way of central services for the data backplane, but also we're looking at how do we use it on the user compute side, right? How do we deploy a Kubernetes platform that will let us move the data and make the data easily visible via Globus. And Globus, again, is already playing an important role in data management, as you saw in the transfers, as well as data distribution. So moving data via Globus is one option already. And again, this just reiterates the fact that we have done something even though we're just starting up. So thank you.